All right, so the next conic section is something called hyperbolas. If you have like a cone stacked on top of another cone, and we chop it like this, chunk, like that, this right here, and this right here, together form a hyperbola. There's like, it's kind of like two parabolas next to each other. Okay, there is a center. There is a focus here and a focus here, so that's a focus. This is a center. This is another focus. If you recall ellipses, you remember what did A represent on an ellipse? What was A? The distance from where to where? Center to the vertex. Very good. Same is true. Oh, by the way, there's a vertex right here. That's a vertex, and that's a vertex. So A is still the distance from the center to the vertex. That is A. So this right here is also A. So center to the vertex, if you just remember it on the ellipses, it's the same center to the vertex on a hyperbola. Do you remember what C represented on an ellipse? Center to the focus. Same thing is true here. This right here, from the center to the focus, is C, and the center to the focus is C. What's bigger, A or C? C. That's different. C is the big daddy in hyperbolas. It is the largest one. So the equation is now C squared equals A squared plus B squared. So it's literally the Pythagorean theorem. A squared plus B squared equals C squared for hyperbolas. B is the distance, well, this is B, that's B, this is B, this is B. It's like a distance perpendicular to this line right here. And if you form a box where this is A and this is B, and you draw lines through the corner of the box, these represent like asymptotes that will generate the shape of the hyperbola. I've made a mess of that, haven't I? All right. So A is the distance from the center of the vertex, C is center to the focus, and B is this. B will become more clear once I give you an example. And the relationship is C squared equals A squared plus B squared. There's two types of hyperbolas. One that goes sideways. For parabolas, a sideways parabola would be the y being squared. It's actually the opposite for this one. Think of it as x being squared first. So if you look at the two equations right here and right here, how is it different than an ellipse? There's only one difference. It's a minus. Very good. So if you've got squared stuff minus some more squared stuff, that's an indication that it's an ellipse. Or I'm sorry, a hyperbola. Okay, that's the only difference. Now, A is not always the biggest one between A and B. A is always the first one. So that's also different with a hyperbola. This is always A squared. In both forms, A squared is first and B squared is second. If A squared is below the x being squared, they open left and right. If A squared is below the y being squared, it opens up and down. So this would be the center, this would be a vertex, and this would be a focus, and a focus like that. All right, so I'll start with an example. Let's see if we can find an equation with the center at the origin and foci at 4, 0, and negative 4, 0. And I'll even give it vertices at 3, 0, and negative 3, 0. All right, so we're going to try to find an equation. I'll start with a sketch. So foci are at 4, 0, vertices are at 3, 0, 1, 2, 3, there's a vertex, 1, 2, 3, there's a vertex. If I go one more, that's a focus, go one more, that's a focus. So is this going to go open left, right, or up, down? Left, right, very good, because this is the vertex. It's going to go like this, and it's going to go like this. I'm going to wait to draw it completely here. Who can tell me what A is here? A is the distance from the center to a vertex. A would be 3. And then C would be 4. Very good. And C is the biggest, so 4 squared equals 3 squared plus B squared. So B squared equals 16 minus 9. So B is the square root of 7. All right. So we're trying to find the equation. Since it opens left and right, that means x being squared is going to be the first. And it's centered at 0, 0, so it's just x squared. And then it's 0, 0, so it's just y squared equals 1. There's my center, 0, comma 0. And A is always first, so A squared is 9, and B squared is 7. Here's our equation. Okay, find out what find the center, A and B, and you have your equation. That's what you need for your equation. If I was going to make a sketch here, I already have I'm going to go up the square root of 7, which is 2.5-ish, and down 2.5. So I'm going to go down about that much. This is B. This is A. So what you do is you make a box. This distance right here is B, and this distance is A. You make a box. The box dimensions are 2A by 2B. Then you draw diagonals that go through the center in each corner. These are just like guiding of what the shape of the hyperbola is going to be. And then the curve converges to those diagonals. So they're asymptotes. And there's the shape. So if you not even close to where it is. Okay, don't make it like this. Make it so that it converges to each dashed line. There's a good accurate sketch. So far so good? Questions? All right, we'll do one more example and call it good for today. Let's see if we can do some stuff here. Y minus 3. All right, your turn to try it. I want you to tell me the center, the vertices, the foci, and do what you can to make a sketch here. I'll give you a couple minutes. All right, so going through this, first thing we have to look at is the center. The center is -1, 3. How many got that far? Good, we're off to a good start. -1, 3, better put my glasses on. Looks like it's right there. Okay, so A is 4, and B is 3. That's always A squared right here, that's always B squared. So C squared equals A squared plus B squared. So C squared equals 16 plus 9, 25. So C is 5. Is this open up, down, or left, right?
Up, down.
Up, down. Below the Y is up, down. Opens up and down. Okay, so I'm going to go 4 up. 1, 2, 3, 4. There's a vertex. Down 4, 1, 2, 3, 4. And if I go 1 further, I have the focus. Focus doesn't help us much on our graph. Okay, So vertices, this is a vertex, negative 1, 1, 2, 3, 4, 5, 6, 7. And negative 1, comma, negative 1. Foci would be one higher, negative 1, 8, and one lower, negative 1, negative 2. Alright, so sketch is the last thing. I have to go B units to the right and left. So 1, 2, 3, 1, 2, 3. Now we can make our box. Box is around like that, because this is A and that's B. We can connect them. And then I'll draw my sketch. How'd we do? Not too bad. It's a matter of keeping all the formulas and we're getting much better at the A's, B's, and C's stuff. And then you just got to remember what A, B, and C represent on hyperbolas.